Hi, I'm Fernando Pereira, and today we continue our course on static analysis. This time, I will try to give you a few reasons on why to learn compilation technology. I will start this presentation quoting Robert Hunt. He's a leading compiler engineer at Google. Once he gave me 3 reasons to learn compilers. If you want, you can stop the video and read them over. But basically, what he was saying is that every single performance percent of improvement matters, and compilers give you this edge. Also, that compiler writers are proficient in many disciplines within computer science, and that many of the most celebrated Google engineers have a compiler background. Indeed, if you follow the Turing Award, the laureate of 2020 were Jeffrey Hillman and Alfred Aho, who wrote the Dragon Book. This is one of the key textbooks in compiler classes. And that's no coincidence. Since its first edition, many compiler engineers have won the Turing Award. And even among the scientists who have not won it, we have some of the most celebrated computer scientists, like Grace Hopper, for instance, who is credited as the inventor of one of the earliest compilers. So, summarizing Robert's perspective, there are 3 reasons to learn compilers. First, that's a way to become a better programmer. Second, because there are many good job opportunities for compiler engineers. And finally, we can better understand computer science in general once we have a better understanding of compilers in particular. Learning compilers imply working with very big and complex systems. Compilers are, next to operating systems, some of the most complex software that we have around. And in addition to being large systems, compilers blend into the same bowl lots of different theories within computer science. We are talking about graphs, language processing, algebra, and lots of other things. The study of compilers is, in the words of Steve Eeg, a nice way to put together all that we learn in computer science. And they are of capital importance to computer science, of course. Imagine how many programming languages we have and how many computer architectures. The compiler must connect these 2 worlds. For each pair of programming language and architecture, there must be a compiler linking them somehow. Another positive aspect of learning compilers is about improving programming skills. Compilers and interpreters are the key tools that we use to run programs. A compiler applies lots of optimizations onto programs. Do you know what these optimizations do? Do you actually know that we can run some of these optimizations individually, or that we can disable some of them whenever that's necessary? And we can spell lots of fallacies about programs and programming languages once we learn some more about compilers. For instance, would we save space by reusing the names of variables? What do you think? Or if I use inheritance, does overloaded methods are they slower to invoke than not overloaded methods? Or if I use macros instead of functions, do the programs run faster? We can find answers to all these questions once we dive deeper into the design and implementation of compilers. In addition to all that, one should remember that there exists a booming market for compiler engineers. There are not that many positions available compared to typical positions for software engineers, which we count in millions of job posts. However, the open positions that exist in the field of compilers pay very well. Nevertheless, one question that comes to mind is, what do compiler engineers do? Another question, of course, is, where do they work? Indeed, they work everywhere. You can find compiler experts in the car industry, for instance. That's because every hardware requires a compiler, and vehicular hardware is no exception to this rule. Indeed, you will find a strong connection between compiler jobs and the embedded system market. We have lots of different computer architectures, all of them with their own requirements in terms of programming language and code generation. And that appeal of the embedded system market becomes each day more attractive with the growing importance of the Internet of Things. Another place where we can find lots of compiler engineers is in the video game industry. That's because game consoles have very particular architectures, and also video games require high performance compilation. We find compiler engineers working in big service providers like data centers, in which high performance is fundamental. And now that machine learning techniques have become so ubiquitous, we also find compiler engineers working in runtime environments, each time more efficient, be it in speed or in memory consumption or even in power dissipation. Indeed, most of the big IT companies in the world have compilers of their own. Here we are talking about tools like those used to run JavaScript, Java, C#, C, and many other programming languages. And there are smaller companies that are specialized in the art and craft of compilers and static analyzers. They might use these tools either as standalone compilers or as bug finders or to implement software protection techniques. You name it. For instance, if you take the example of JetBrains, the company that produced IntelliJ and Kotlin, you will see that this is a genuine compiler company with lots of uses for the techniques that we shall learn in this course. And with this last example, I close this class. In the next class, we shall see a bit of the kind of material that will be covered in the course.